pertinent to have a look at a question which deals with this topic, that is reflection. Coming up is an example on a combination of reflection, translation, rotation. Then the main part of the example is that of reflection. So let's look at it. The point 4,1 undergoes the following transformations successively. Successively meaning one after the other. Reflection about the line y equals x minus 1, and then translation by 1 unit along x-axis in the positive direction, and then rotation through an angle pi by 4 about the origin in the anticlockwise direction. The coordinates of P in the final position, that is after all three transformations are completed, is which of the following? So first thing, 4,1. So we need to have a rough picture of where 4,1 will be if we draw it, or if we plot this point on a graph paper. It undergoes reflection about the line y equals x minus 1. So the next thing that we should have a rough idea about is where and in what inclination is the line y is equal to x minus 1 located. So therefore, if we have x-axis and y-axis like this, then the line y is equal to x minus 1 will be like this. And the point 4,1 will lie somewhere over here. Now, the point is reflected about the line y is equal to x minus 1. So x minus 1 acts as a mirror. Suppose this is the point where we start, 4,1. So the reflection will be somewhere over here. Let's call it Q. We have to find the coordinates of the point Q, because only after that can we find out where the second step will bring the point to. Okay, so let Q be x1, y1. So x1 minus 4 divided by, okay, so the line y is equal to x minus 1 can also be written as x minus y minus 1 is equal to 0, so that a equals 1, the coefficient of x, coefficient of y is minus 1, and the constant term is minus 1. So x1 minus 4 divided by a equals y1 minus 1 divided by minus 1 equals minus 2 times 1 into 4 minus 1 into 1 minus 1 divided by a square plus b square, so 1 square plus minus 1 square. So this gives us x1 is equal to 4 minus 2 is equal to plus 2. Similarly, we will get y is equal to 1 plus 2. So that's equal to 3. So this is the point Q. After step 1 of the transformation is completed, what is the next step? Translation by 1 unit along x-axis in the positive direction. So let's call that point R. R is Q translated by 1 unit in positive x direction. So R is the point 3, 3. And third, it is rotated by pi by 4 in the counterclockwise direction. Notice here that R is the point 3, 3. What is so special about the point 3, 3? It is going to be on the line y is equal to x. And we know that y is equal to x is a special line. Why? Because it passes through origin, and secondly because it is inclined equally between the x-axis and y-axis. So therefore, if this point is rotated about the origin, suppose this point is located here on the line y is equal to x. And so rotation by pi by 4 will bring it to the y-axis. And so let's call that point S. Now the only thing that will be common between OS and OR is the length. What is the length of OR? OR can be obtained by using the Pythagoras theorem, and that will be 3 times square root of 2. And so OS will also be 3 root 2. But S is a point lying on the y-axis. And so the coordinates of the point S will be 0, because the coordinates of any point lying on the y-axis is 0. The x coordinate is 0, and the y coordinate will be the length of the line segment OS, 3 root 2. And thus, after the 3 transformations, the point P will end up with the point S, whose coordinates are 0, 3 root 2. And so, point C, the option C would be the correct answer.